Welcome to the deep dive. Today we're really cracking open a document that feels, well, less like a typical white paper and more like an actual operational manual for, the next wave of business tech.
hmm
We're diving into the IBM Guide to Architecting Secure Enterprise AI Agents, and it uses something called the Model Context Protocol, or MCP. What's really interesting is this guide was verified by Anthropic just now, October 2025, so it's giving us a pretty fresh roadmap.
Yeah, that date 2025, it's really key, isn't it? This isn't some far off theory. It's about operational readiness, like right now.
Right.
So our mission today really is to break down this agent development life cycle, the ADLC, and the whole architectural framework you need. Because moving these autonomous AI agents out of the lab and, safely into real business functions, that's the goal.
Okay.
And it means rethinking, well, pretty much everything: security, reliability, and maybe most importantly, compliance.
So when you look at this whole guide, what's the single biggest problem IBM is trying to tackle here? Because it feels like you can't just treat these AI agents like, I don't know, another complex piece of software.
That's exactly it. That's the fundamental shift. The core challenge here is the massive difference between the old way, the software development lifecycle, SDLC, and this new agentic world.
Okay.
See, traditional software, it's static, it's deterministic. If I run a payroll script 10 times, same input, I expect the exact same output every single time.
Predictable.
Predictable. Agents, though, they're adaptive, they interact, and crucially, they are inherently probabilistic, non-deterministic, because they're powered by LLMs.
So wait, an agent that's live, in production, could actually give different results even if you feed it the exact same data, the exact same prompt,
Yeah,
just because of how the model works underneath.
exactly. The guide spells this out, that variability. It's fundamental. It could be a tiny change in the model's internal state, or maybe even just the random seed it used for that particular run.
Hmm.
So identical tests can genuinely give different results, and that just, well, it blows up traditional testing and validation, doesn't it?
Simply, yeah.
Which forces us to create this ADLC. It's a new structured way of operating, built specifically to handle these, probabilistic systems safely when you're dealing with enterprise scale.
All right, so we're going to break this guide down section by section. We'll walk you through it almost like a course, laying out the blueprint for what IBM is calling the agentic enterprise. Think of us as your guides, navigating these architectural needs one topic at a time.
Sounds good.
Let's jump into section 1 then.
Mm-hmm.
What exactly is an AI agent in this context, and why does it force this whole paradigm shift?
Okay, so AI agent. We hear that term thrown around a lot. But for this IBM guide, this enterprise focus, what's the specific definition we need to work with?
Right. It's definitely more than just a chatbot. The definition here is quite specific. These AI agents are software systems that combine 4 key things. They have memory, right? So they know the context across interactions.
Mm-hmm. They use planning. They can break down big goals into smaller, manageable steps. They also use reflection, meaning they can sort of self-correct and check their own progress. And critically, they use tools. They interact with external services, APIs, databases, you name it.
So they sense the context, reason about goals and constraints, and then acts using these tools to get multi-step tasks done. It's that combination, memory, planning, reflection, tool use, that makes them more than just processing systems. They're decision-making and execution systems.
Precisely. That's the core idea. They're integrating data, integrating applications, using these tools to break down complex jobs and coordinate all the subtasks. Now, when we talk specifically about enterprise AI agents, we layer on the business reality.
The constraints.
Exactly. They might be autonomous or semi-autonomous, but they absolutely must meet strict enterprise needs. Things like observability, security, compliance, resilience, and of course, scale.
And where they run matters too, right? They're not just off in some isolated cloud bubble.
Not at all. The guide is clear. They need deployment flexibility. They have to work across hybrid clouds, public, private, even traditional on-prem data centers. They have to respect data sovereignty rules wherever that data lives.
Makes sense.
And they need model flexibility, too. You might use a mix of models, maybe smaller, fine-tuned enterprise ones for speed, maybe larger frontier models for the really complex reasoning. It all depends on the quality, latency, and let's be honest, the cost you need for that specific task.
Okay, let's unpack that paradigm shift again. This is where I imagine traditional software folks really feel the ground move. You mentioned the first big difference, from deterministic to probabilistic.
Yeah.
What were the other 2 key shifts the guide highlights?
Right. So the second big one is the shift from static to adaptive. Think about traditional apps. Once you ship version 1.0, its functionality is fixed, right? It behaves the same way until you patch it with version 1.1.
Mutable.
Agents, though, they can learn. They evolve. Their behavior can actually change dynamically based on the interactions they have, the feedback they get. This means the agent running in production 6 months down the line might act quite differently than it did on day one, even if you haven't touched the code.
Wow. Okay, that makes things like change control
Yeah.
challenging if you don't build for it.
Absolutely. Which brings us to the third and maybe the most operationally critical change, the shift from code first to evaluation first.
Evaluation first. What does that mean in practice?
In the old SDLC world, we measure success by, implementation details. Does the code compile? Does it pass the unit tests? Green checks everywhere.
Standard stuff.
With agents, the guide says very directly those traditional metrics. They just don't predict success anymore.
So we stop worrying so much about if the code looks perfect and start focusing purely on whether it works.
That's the shock, isn't it? Agent success isn't really about how clean your prompt is or how elegant the orchestration code looks. In fact, the guide even notes that sometimes a really messy, convoluted prompt might actually work brilliantly for a specific task.
Huh.
Success hinges way more on systematically and continuously measuring the agent's behavior and the actual business outcomes it produces. Is it hitting the goal? Is it staying within its safety rails? Is it using tools correctly? That's what matters. The focus shifts entirely to the evaluation, the observable results, not just the code itself. You only ship when you have solid behavioral evidence.
All right, shifting gears now to this idea of the agentic enterprise. It sounds like this isn't just about plugging in a new tool. It's about fundamentally changing how IT operates because these agents are going to touch, well, everything.
That's exactly right. Agents don't live in isolation. This ADLC thing we're talking about, it has to weave seamlessly into the whole existing enterprise fabric. Your hybrid cloud setup, your data platforms, your core business apps, all the management tools you already use.
They have to play nice with others.
And respect the rules. They need to be aware of and strictly adhere to all the enterprise controls. Things like resilience targets, risk-based security policies, data sovereignty rules, regulatory constraints, you name it.
Okay, so to help structure this big transformation, the IBM guide lays out 6 core design principles, like the pillars for building any enterprise agent architecture. Can you walk us through those?
Sure. These pillars are really about ensuring control and compliance. First up is acceptable agency. Basically, we need to define and actively control how much autonomy the agent actually has. It can't just run free.
Makes sense. Control the leash.
Second, interoperable, secure by design. Agents have to plug into existing tools easily, and security needs to be baked in from the start, not bolted on later. Third, evaluated. We talked about this. They need continuous evaluation against business goals while also managing risk. That evaluation-first mindset has to be part of the design.
Okay, so agency, interoperability, evaluation, what are the other 3? They seem focused more on deployment and keeping things running.
Exactly. Fourth is securely deployed. Agents have to be rolled out safely across that complex hybrid cloud landscape. Fifth, continuously observed and managed. This is key for resilience and importantly for catching any behavioral drift over time.
Right, making sure it doesn't quietly go off the rails.
And sixth, governed. Governance has to be woven through every single step. That's what enables you to meet enterprise risk and compliance standards. Honestly, governance is what makes using these things in a real enterprise possible at all.
Now let's dig into the specific development requirements, especially thinking about those highly regulated industries like finance or healthcare. The guide seems to suggest we need way more upfront work in planning and building.
Yeah, the requirements get much heavier, starting right in the planning phase. One big challenge, especially in regulated fields, is you often can't just use historical production data for testing. Think IPA or internal PII rules.
Right, privacy constraints.
So the guide says developers must generate high-quality synthetic ground truth data. This gives you reliable, safe benchmarks for testing right from the beginning. You also need solid vendor evaluation frameworks if you're using third-party stuff, and critically, enterprise-grade role-based access control, RBAC, designed and integrated from day one, not as an afterthought.
And then when you get to the code and build phase, it's not just about versioning your code in Git anymore, is it?
Oh no, you need version control for everything. Your prompts, the models you're using, the tool sets the agent interacts with. You need much more advanced experiment tracking, especially if you're juggling multiple agent variations trying to find the best one.
Okay.
And this is crucial. You need specialized vulnerability scanning. Your traditional scanner might look for SQL injection in Java code. These new scanners, they need to look for things like prompt injection, trying to trick the LLM, or data poisoning, or other adversarial attacks aimed right at the AI layer itself.
That's a whole new threat landscape. So when we move to testing and release, those evaluation frameworks we talked about need to be plugged right into the CI/CD pipelines.
Absolutely. It's not just a final quality check anymore. It's a continuous governance check. You're automatically monitoring for behavioral drift, checking accuracy against benchmarks, tracking costs all the time. Governance gets enforced through things like certified catalogs only approved, vetted agents get promoted, and secure API execution for the tools they use.
Okay. And finally, deployment and operations. The guide keeps coming back to one specific security control: sandboxing. Why is that so central?
Sandboxing is just fundamental here. Think about it. Agents can execute dynamically generated code, maybe code suggested by the LLM itself, and they interact with potentially dozens of different tools, some internal, some external, some handling sensitive data.
That sounds inherently risky.
It is. So the guide treats isolation sandboxing as pretty much mandatory. Without it, if an agent gets compromised somehow or just goes off script, it could potentially move laterally, accessing systems or data way outside its intended job. Deployment needs that compliance-aware infrastructure, sure, like HIPAA-certified regions, but sandboxing is the baseline control you need to run this potentially untrusted, dynamic executions safely, especially in a complex hybrid environment.
Got it. So sandboxing isn't just a nice-to-have security layer. It's basically a prerequisite for running these agents responsibly in an enterprise setting where you have to strictly limit what they can access. Okay, let's dive deep into the ADLC itself now. The guide positions this as the comprehensive framework built on familiar DevSecOps ideas, but significantly extended. Extended specifically to handle that stochastic control logic, the agentic reasoning, which is what makes these applications behave so differently.
Right. The guide is clear that the core principles of DevSecOps still hold true. Continuous integration, continuous security testing, continuous monitoring, all that is still foundational.
But it needs more.
It needs radical expansion. For example, shift-left security in the old world might mean running static code analysis early. Here, it means things like integrating agent identity management and using standards like the Model Context Protocol right from the design phase. It's about securing the agent's behavior and interactions, not just checking for flaws in the orchestration code.
And critically, the ADLC introduces two completely new feedback loops that you just don't need in traditional software development. These seem directly tied to that probabilistic nature we discussed.
Yes, exactly. These two new inner loops are really the game changer. First, you have the experimentation loop. This cycles tightly between the build and test phases. Why? Because results vary. You have to constantly iterate.
Right.
So this loop embeds agent evaluation frameworks and continuous benchmarking right into the build process. The goal isn't just fixing bugs, it's actively improving the agent's behavior, making it smarter, safer, more reliable through repeated testing and refinement.
Okay, so continuous improvement through testing. What's the second new loop?
The second one is the runtime optimization loop. This operates after deployment in production. It allows for things like dynamically scaling inference resources based on load. But more importantly, it enables continuous monitoring of the agent's quality and, crucially, continuous optimization of its operational costs.
Optimizing costs in real time. How does that work?
Well, maybe the loop detects that for certain types of tasks, a smaller, cheaper model performs just as well. Or maybe it finds a simpler sequence of tool calls that achieves the same result with less latency or fewer API charges. It's about constantly tuning the agent's operation in production to maintain quality while minimizing cost.
That second loop sounds like it has massive business value. If you can constantly shave pennies off every task the agent performs, that adds up incredibly fast.
Absolutely. Maximize that ROI in real time.
Okay, let's trace how the ADLC extends the familiar DevSecOps phases, starting right at the beginning with plan.
Plan really embodies that evaluation-first mindset. You have to define the agentic behavior specification. What is it supposed to do? And you need to document standard operating procedures, often in natural language, almost like an internal compliance manual for the agent itself.
So setting the rules up front.
Exactly. And setting clear, measurable KPIs right at the start. Things like target accuracy, latency requirements, maybe even trust scores, and definitely define safety thresholds. And critically, you define the explicit authority boundaries, what it can and cannot do, along with the required human-in-the-loop paths for sensitive actions. You establish those trust boundaries before a single line of code is written.
Moving into code and build. Obviously, you're writing the core logic, the prompt engineering, the memory strategies, but what are the new security must-haves here?
Secure by design has to be embedded here. A huge piece is instrumenting observability hooks deep inside the agent's logic. These hooks capture what the guide calls agent transcripts.
Agent transcripts, like a black box recorder.
Sort of. They capture the full reasoning, trace the chain of thought, which tools were called, with what parameters, what the outputs were. Without this detailed transcript, trying to audit a failure later is almost impossible. And just as critical, every single agent needs to be issued a unique identity. This identity needs to be tied into your existing enterprise RBAC systems for full traceability and auditability. You need to know which agent did what.
And the guide describes this layered defense strategy, right?
Right.
Combining two different levels of security seems essential because fundamentally you can't fully trust the output or behavior of the LLM itself.
Precisely. That layered defense is key. You combine infrastructure-level controls, specifically sandboxing, with policy enforcement at a gateway layer. So you sandbox the agent and its tools. Often using lightweight isolation like Firecracker or gvisor, you can think of these as creating tiny, disposable, secure micro-VMs that lock down what the agent's code execution can actually touch.
Okay, so isolation prevents lateral movement if the agent messes up or gets tricked.
Right. And then you complement that base isolation with runtime policy enforcement, typically at an MCP gateway, which we'll discuss more later. This gateway handles centralized rate limiting, it can filter prompts for malicious content, enforce access controls based on the agent's identity and the context. So isolation at the execution level, regulation at the network or API boundary.
That really minimizes the blast radius if something goes wrong. Okay, so we get to the test, optimize, release phase. The focus here shifts completely away from just unit tests to actual behavioral validation.
Yes. This is where you run structured evaluations using test data that really mimics production scenarios. And critically, you often need ground truth, not just for the final answer, but for the expected reasoning path or trajectory the agent should have taken.
How do you even test that?
You use continuous guardrails. One technique mentioned is LLM as a judge, or LLM AJ, basically using another separate LLM specifically trained to evaluate the output of your agent for things like quality, safety, groundedness in provided facts, or adherence to rules.
Using an AI to judge another AI.
Exactly. And human review is still essential, especially for high risk or sensitive areas. You can't fully automate trust yet.
And the security testing here is about proving safety before it gets anywhere near production.
Right. It involves rigorous security testing, specific red teaming exercises designed to provoke failure modes, try to jailbreak it, try to make it leak data, try to make it misuse tools. You run continuous validation checks against those KPIs set in the plan phase.
Are there specific metrics mentioned?
Yeah, things like measuring the hallucination rate, how often does it state facts not supported by the context it was given, using specific guardrail models to detect bias, toxicity, or non-compliant language in the output. An agent only gets certified and added to that governed catalog after it demonstrably meets all the predefined quality and risk thresholds.
Once it's certified, the deploy phase kicks in, focusing heavily on resilience. And this includes something pretty dramatic.
Kill switch. Yeah, the mandatory inclusion of a kill switch really underscores the necessary caution around autonomous systems. If an agent starts behaving erratically, maybe due to model drift or unforeseen interactions, what the guide calls agentic drift, you need an immediate, reliable way to shut it down across the entire enterprise.
Pull the plug.
Pull the plug. And sandboxing gets re-emphasized here again as a baseline control, particularly crucial for deployments where the agent might execute untrusted or dynamically generated code, like using a code generation tool, or if it's handling highly sensitive data.
Then we hit the monitoring phase. This is where that runtime optimization loop really comes into play, and where you track those unique agent-specific threats.
Exactly. We're monitoring for things that just don't exist in traditional software, like memory poisoning someone, maliciously feeding bad information into the agent's long-term memory store to skew its future behavior, or deliberate misuse of tools or APIs. Alongside that, you're constantly tracking accuracy, latency, cost, safety flags. This rich monitoring data is what generates the insights that feed back into the experimentation loop for continuous improvement.
Okay, finally, the operate phase seems to bring it all back to governance and long-term auditability.
This is where you maintain that curated catalog we mentioned. It's the central registry. It tracks every deployed agent, documenting its owner, its current version, its mandated risk posture, and crucial links to all the auditability evidence records of past evaluations, compliance approvals, configuration settings.
So the living record of the agent,
Exactly. And it includes ongoing audits, for example, checking for fairness across different demographic groups if the agent interacts with customers. The guide also mandates secure retirement processes. When an agent is decommissioned, you need to securely archive its data, its transcripts, its configurations, potentially for years, to meet regulatory requirements.
And this whole ADLC process is structured by specific gate checkpoints, right? What are the absolute must-haves to move from one phase to the next?
Yeah, the gates enforce that continuous compliance. You can't just push things through. To move out of development, for instance, you need a past design review, which must include defining those authority boundaries. To get into testing, you need evidence that initial behavioral evaluations meet the minimum quality and risk threshold.
And for deployment?
For deployment, you need formal change advisory board approval. They review the rollout plan, the rollback strategy, and critically, they verify that the kill switch mechanism and monitoring alerts are correctly configured and tested. The final gate before full production release requires formal sign-off confirming all compliance reviews are complete, backed by the audit logs and data lineage captured throughout the entire ADLC process. Security and compliance aren't optional extras, they're embedded at every stage.
This naturally leads to a really fundamental question, doesn't it? With all this overhead, the ADLC, the sandboxing, the gateways, the catalogs, when does it actually make business sense to invest in building an agent? Because the guide seems pretty blunt about avoiding complexity if you can.
It is. The core recommendation is stark. Find the simplest possible solution that works. Agents, remember, inherently trade off increased latency and cost for potentially better performance on complex tasks.
So don't build one if you don't have to.
Exactly. If a straightforward retrieval augmented generation, or RAGO, system can do the job, or maybe even just a really well-crafted prompt for a standard LLM call achieves the business objective, say, classifying 90% of incoming support emails accurately, then the guide says you should absolutely not build a complex multi-step agent for that. The overhead isn't justified.
That complexity sounds, well, enormous. All that sandboxing, cataloging, continuous behavioral evaluation. Just to replace what might have been a simple script, when does the return on investment possibly justify all that?
The ROI kicks in when the problem genuinely requires contextual judgment or complex multi-step decision-making, or involves synthesizing information from lots of different places. That's where agents shine.
Can you give an example from the guide?
Sure. The guide points to successful uses like generating a comprehensive research report for a new business strategy. An agent could be tasked to gather data from internal databases, external news feeds, maybe competitor websites. Then it needs to analyze that data, identify conflicting information, draft the report structure, generate the text, maybe create some charts using a tool, and then refine the whole thing based on self-reflection or even human feedback.
Ah, okay, so that multi-step dynamic process involving judgment and synthesis across systems, that's where the agent overhead starts to make sense.
Exactly. If the task needs true judgment and adaptation, the agent might be necessary. But if it's just simple classification or retrieving a specific fact, probably massive overkill.
Makes sense.
And managing that complexity is critical. The advice is clear. Start with single agent solutions first. Get that right. The guide explicitly warns that trying to build multi-agent systems where different agents collaborate and coordinate tasks among themselves, well, that adds significant, almost exponential operational complexity.
How so?
You run into nightmares like coordination failures, deadlocks between agents, figuring out how to observe and trace interactions across multiple independent agents. You really need to master the single agent ADLC before you even think about tackling multi-agent orchestration.
Okay, good warning. The document does highlight 3 specific application areas, value patterns they call them, where enterprises are apparently seeing consistent value that justifies this high complexity bar.
Right. First is customer support and service. This is probably the most mature area. Agents handle routine inquiries, maybe guide users through troubleshooting, but the complexity justifying the ADLC here comes from needing really strong evaluation frameworks, ensuring the agent leverages diverse knowledge bases correctly, and having crystal clear rules for when to hand off to a human agent managing those acceptable agency boundaries.
Got it. Second area.
Second, document-heavy processes. Think contracts, compliance documentation, scientific research. Agents can add huge value here by routing documents, validating information within them, summarizing key points, synthesizing findings across thousands of pages. But this only works well if you have relatively structured inputs and, crucially, if the outputs are highly verifiable and auditable, you need to trust the synthesis.
And the third area seems focused on helping out expensive human experts.
Yeah, knowledge work and development augmentation. Here, agents act more like assistants for researchers, analysts, software developers. They can help with deep research, analyzing complex data sets, suggesting code snippets, drafting documentation. Success here really hinges on having tight feedback loops with the human expert and very well-defined standards for the tasks the agent is assisting with. The agent isn't replacing the expert, it's boosting their capacity.
And just to reiterate, the reason this entire ADLC framework exists, the reason for all this complexity, comes back to the unique security and risk challenges these autonomous agents introduce.
Absolutely. The risks are profound precisely because of the autonomy. You have the inherent risk of autonomous decision-making. What if an agent makes a choice that violates compliance? Maybe it denies a loan application based on criteria that turn out to be biased, learned from the data, or it says something damaging to a customer, causing reputational harm.
Right.
Then you have the expanded attack surfaces. The conversational interface itself is a new vector. We talked about prompt injection. And the agent's autonomous use of tools, if it can trigger financial transactions or access sensitive databases, that's a huge target.
So the prompt itself becomes a potential vulnerability.
Exactly. And finally, there's the compliance complexity. If you're in finance or healthcare, regulators need to be able to audit why a decision was made, being able to reconstruct the agent's exact reasoning path, which tools it accessed, what data it saw that's non-negotiable. And the probabilistic nature makes this kind of forensic auditing incredibly difficult without the rigor and observability built into the ADLC.
Okay, Section 5 really digs into observability and security. It highlights this critical shift in thinking. We're moving away from the basic infrastructure question, is the system up, to something much harder. Is the system doing the right thing safely and correctly?
Yeah, this is absolutely core. Because agents aren't deterministic, figuring out why something went wrong is way harder than debugging traditional code. You need incredibly rich traces just for reproducibility.
Reproducibility.
Yeah. If an agent gave a bad answer or took a wrong turn, you need to be able to reconstruct the entire context it had at that moment. How did the conversation evolve over multiple turns? Which tools did it call exactly? What parameters were passed? Did it retry? What errors came back? You need to capture all the side effects of its interactions. The correctness of the agent and your ability to fix it depends entirely on being able to observe that dynamic flow of reasoning and action.
So the basic building blocks for observability have to go way beyond standard application logs. What kind of telemetry coverage are we talking about?
We're talking total coverage. Yes, you need traditional logs and traces, but you also need agent-specific things. Events, like when the agent decides to reflect or replan, detailed inputs and outputs for each step, token and cost accounting because usage can be volatile and expensive, and safety flags that get triggered by your guardrail models if the agent tries to say or do something risky.
Wow.
You need a holistic view. The guide uses the acronym MELT. Metrics, events, logs, and traces, all integrated end-to-end so you can correlate across these different signals to understand the agent's behavior.
And all this rich data then feeds into the evaluation process. The guide breaks down evaluations into, I think, 4 key types based on where they happen.
Right. You've got offline evals, which are typically run during CI/CD for benchmarking against test datasets. Then online evals, which run continuously in production to measure quality and safety against live traffic.
Okay, those sound somewhat familiar. What about the other types?
The more advanced ones are in-the-loop evals. These are checks that get invoked dynamically during the agent's actual reasoning process. For instance, in a RAG system, before the agent uses a retrieved piece of text to formulate its answer, an in-the-loop eval might check if that text is actually relevant to the user's question. It acts like a real-time safety or quality check within the agent's thought process.
Like a fact checker whispering in its ear.
Kind of. And the metrics framework that these evals track covers the whole spectrum.
Right, not just accuracy.
No, everything. Quality metrics like groundedness, does the answer stick to the facts provided? Tool call success rates? Safety metrics like jailbreak attempt rates, sensitive data leakage detection, operational metrics like latency and cost per task. And of course, linking all this back to core business metrics like user satisfaction or task completion rates. All this evaluation data gets aggregated to generate insights at what the guide calls the agentic flow level.
Can you break down the difference between those insights? It sounds like we're moving beyond generic system is slow, alerts to much more specific diagnoses.
We really are. A multi-flow insight might be an aggregate view like, hey, overall agent response quality dropped by 10% across all users last Thursday. Useful, but broad.
Okay.
A single flow insight drills down into one specific user interaction to find the root cause. For example, the system flags a conversation where a user gave a thumbs down after asking about benefits for veterans. By tracing that specific flow, the observability system might reveal the agent tried to call a tool to get veteran-specific info, but it used an outdated API endpoint and failed, leading to a generic, unhelpful answer and user frustration.
Ah, okay, very specific. And a message-level insight.
That zooms in even further, maybe looking at a single turn in the conversation. Perhaps it flags one particular response that took way longer than usual. Correlating that message with the underlying telemetry might show it was due to an unexpectedly high token count generated by the LLM, or maybe a specific tool call that timed out and had to be retried multiple times.
Got it. And these super granular insights then drive automated fixes or feedback into that experimentation loop to improve the prompts or tool usage.
Precisely. Now, shifting to the security side of this section, the guide does a good job of mapping the technical risks we've touched on to 4 really critical business-level challenges. These are the things that should keep executives up at night.
They sound pretty severe if you don't address them.
They are potentially catastrophic. The first big challenge is uncontrolled access and privilege escalation. Because agents can act autonomously, they might try to gain access or permissions they shouldn't have, potentially bypassing human approvals and creating huge accountability gaps. Who's responsible if the agent transfers funds incorrectly?
Oof. Okay, what's next?
Second, agent-enabled data leakage and prompt exploitation. This covers both malicious prompts trying to trick the agent into revealing sensitive info and also just the non-deterministic nature where the agent might accidentally include PII or confidential data in its response.
The third one sounds particularly scary. The agent itself becoming a weapon.
Yeah, autonomous attack amplification. Imagine a compromised agent, or even just a poorly designed one, being used to launch attacks from inside your enterprise network. It could probe systems, exploit vulnerabilities, maybe even coordinate with other compromised agents like a botnet, all happening at machine speed. It could compress the timeline for a major breach dramatically, overwhelming human defenders.
That's terrifying. And the fourth risk?
Agentic drift and noncompliance. This is more subtle. The agent, through its learning and adaptation, might slowly, quietly drift away from its original approved behavior or operating parameters. It might start violating compliance rules or internal policies in ways that aren't immediately obvious, undermining regulatory adherence over time without anyone noticing until it's too late.
Okay, those are serious business risks. So, to counter these, the guide proposes 4 targeted solution areas.
Right. First, you need robust agent identity and access. Every agent gets a unique, verifiable identity tied into your RBAC, enabling fine-grained, context-aware access control. Least privilege is paramount. Second, agent and data protection. This involves using things like MCP gateways to filter prompts for malicious content, encrypting data in transit and at rest, and crucially, enforcing that secure deployment isolation using sandboxing.
Protecting the agent and the data it touches, and then using AI to fight AI.
That's the idea behind autonomous agent defense, using AI-powered monitoring and threat hunting tools specifically designed to detect the weird behavioral anomalies that might indicate an agent compromise or misuse, things that traditional security tools might miss. And finally, agent security risk and compliance. This means integrating agent-specific risks into your overall risk management framework, continuously monitoring configurations for drift against compliance baselines like IPOSE or GDPR.
And this risk management has to extend beyond just the agent itself, doesn't it?
Absolutely critical point. It has to cover the entire agentic AI system supply chain. That includes any third-party agents you might use, the tools they connect to, internal or external, and the underlying foundation models. This requires demanding things like software bills of materials, SBOMs, not just for code, but for prompts and tool configurations too. It means enforcing artifact signing and verification, scanning dependencies, and running continuous audits on the whole ecosystem.
Okay, Section 6 brings us squarely to governance, testing, and this MCP standard. Governance seems like the overarching framework that makes the ADLC actually operational and safe at scale.
That's exactly how the guide positions it. Governance provides the controls, the policies, and critically, the evidence needed to safely deploy and scale these inherently non-deterministic systems. It's not just about rules, it's about proof.
And the central piece of this governance structure seems to be the governed catalog. What makes this more than just a list of deployed agents?
It's much more. This catalog is the authoritative source of truth. It has to document, for each registered agent, its specific authority boundaries. What is it allowed to do autonomously? What actions always require human review or approval? Where are the hard lines drawn?
So it's operational rights and limits.
Exactly. It also details the required data handling policies. How must this agent classify data it encounters? Are there specific masking or anonymization rules it must apply? What are the data retention requirements for its inputs and outputs? And third, it ensures auditability. The catalog must link to the systems that provide an immutable trail of every decision the agent makes, every tool it calls, every significant side effect it causes.
So the catalog defines the agent's legal and operational mandate, essentially. And to make sure agents actually stick to that mandate, especially given their probabilistic nature, we need that rigorous experimentation tracking and lineage we touched on earlier.
Yes, that traceability is non-negotiable for governance. Because results can vary even with the same code, you need to capture detailed metadata about every single experiment run that might lead to a new agent version being considered for promotion.
What kind of metadata are we talking about?
Everything needed to potentially reproduce that run. The specific version of the dataset used for evaluation, the exact prompt version often captured as a prompt hash to ensure immutability, the foundation model version and its parameters, the versions of all the tools the agent used in the test, the code commit ID, even the version of the evaluation suite itself. It's exhaustive.
And all this metadata comes together to create something the guide calls the reproducible manifest. This sounds like the ultimate audit artifact for a probabilistic system.
It really is the gold standard for auditability in this world. The reproducible manifest is essentially a digitally signed list that locks down the exact configuration of a specific agent version that was tested or deployed. It pins the fixed versions and unique identifiers for every single component. The agent's orchestration logic, all the tools it's authorized to use by version, the exact prompt via their hash, the specific model ID, and all its software dependencies.
So it's the definitive proof of exactly what was running.
Precisely. If a regulator comes knocking 6 months later and asks, show us exactly why agent version 2.1 made this specific decision on this date, the reproducible manifest provides the concrete evidence. It proves that version 2.1 was running prompt hash ABC on model XYZ using toolset 7.4. Without that level of traceable detail, you can't really claim governance.
Okay, so the catalog sets the policy, and the manifest provides the immutable hashed evidence that the policy was followed for a specific version. That linkage feels absolutely central to making this enterprise ready.
It is, and this rigor extends to versioning discipline. Agents, tools, prompts, they all need clear semantic versioning. You have to pin specific model IDs, not just use latest. And the guide emphasizes generating not just traditional software SBOMs, but also prompt SBOMs.
Prompt SBOMs. A bill of materials for the prompt itself.
Yeah, think about it. The prompt contains intellectual property, potentially sensitive instructions, and it might even inadvertently embed vulnerabilities or biases. Tracking its components and lineage is just as important as tracking code dependencies.
Wow, okay. This extreme level of auditing and control is clearly needed because these agents are interacting with the business through tools. And those tool interactions need to be standardized somehow. This brings us to the Model Context Protocol, MCP.
Right. MCP is positioned as the open standard designed to fix the integration nightmare. It defined a standard way for AI applications, the clients, like our agents, to interact with the systems where context, data, and actions actually reside the servers, which expose enterprise capabilities.
Why is that standardization so important? Couldn't we just keep building custom REST APIs for everything?
You could, but it becomes unmanageable and insecure very quickly at scale. Imagine trying to govern an agent that might need to talk to hundreds of different internal and external APIs, each with its own authentication method, its own way of describing what it does, its own error handling. It's chaos.
Okay, point taken.
MCP aims to standardize that interface. It provides a consistent way for agents to discover what capabilities are available, understand their potential side effects before calling them, and then invoke them safely within well-defined, auditable boundaries set by the server owner. It makes enterprise capabilities reliably and securely accessible to agents.
And the core concepts MCP defines are tools, resources, and prompts.
Correct. Tools are the executable actions. They change things in the world, create a support ticket, update a database record, send an email. And crucially, they must disclose their potential side effects. Resources are primarily read-only data sources the agent can query to get context-retrieve customer history, fetch product details. They inform the agent's decisions. And prompts within MCP refer to standardized interaction templates that can ensure consistency, maybe for common tasks or data formats. The goal is for MCP to become the default, trusted, governed interface for all agent-accessible capabilities within the enterprise.
All right, so we have these MCP servers exposing tools and resources in a standardized way. But how do you manage access and policy across potentially hundreds or thousands of these servers and dozens of different agents wanting to use them? The guide strongly recommends the MCP gateway pattern.
Yeah, the gateway becomes pretty much essential once you move beyond trivial deployments. It's the key to achieving centralized control, security, and scalability. If you think of the individual agents as maybe highly privileged employees needing access to various corporate resources, then the MCP gateway acts like the central security checkpoint or maybe the CISO's office. It stands between the potentially unpredictable agents and the sensitive enterprise systems exposed via MCP servers. It's the single policy-enforced entry point for all tool requests.
So it's like a CISO proxy for the agents. What are the main jobs of this gateway? What does it actually do?
It has several critical responsibilities. First, just basic centralized control. Things like handling authentication for the agents, routing requests to the correct backend MCP server, enforcing rate limits and quotas so agents don't overload systems.
Standard gateway stuff.
Standard but essential. Second, and this is huge, it acts as a crucial security boundary. It can terminate TLS-MTLS connections. It can broker complex authentication tokens, like exchanging an agent's internal credential for an OAuth token the backend system understands. And really importantly, it performs prompt security.
Prompt security at the gateway level. How?
It can inspect the requests, including data being sent in prompts or tool parameters, looking for known patterns of prompt injection attacks, or filtering out malicious payloads before they even reach the agent's core logic or the backend tool. It's a critical defense layer.
Okay, that makes sense. What else does gateway handle?
Policy enforcement is central. It's where you apply your centralized policies, maybe using something like Open Policy Agent, OPA. You can enforce which agents are allowed to call which tools, check if certain high-risk operations require specific approvals logged elsewhere, maybe enforce data masking rules. It also typically handles multi-tenancy, ensuring isolation between different environments like dev, staging, and production.
And governance. Reliability.
For governance, it provides standardized, centralized audit logging for all requests and decisions. For reliability, it's the natural place to implement things like high availability, load balancing across MCP server instances, circuit breakers to handle failing backends gracefully, and yes, those emergency kill switches we talked about, you could implement a kill switch at the gateway to disable a specific faulty tool for all agents instantly.
Okay, the gateway is clearly the central control point. Let's zoom in on the security needed for the MCP servers themselves, the things behind the gateway. If the gateway is the CISO, what are the security duties of the actual tool owner?
The absolute mantra here is least privilege. For identity and access on the server itself, you need robust authentication, probably leveraging OAuth tokens provided via the gateway. Access should be read-only by default. Any action that modifies data or performs a sensitive operation requires explicit, fine-grained authorization, often based on specific roles or scopes asserted in the token. High-risk stuff, like initiating a payment, that should probably require very specific roles or maybe even multi-factor approval logic brokered by the gateway.
And for safety, you have to assume the agent calling the tool might be malicious or just confused, right? So input validation is key.
Absolutely critical. The MCP server needs strict input validation based on defined schemas for all parameters. You cannot trust the data coming from the agent. And just as important, all outputs returned by the tool must be rigorously sanitized before being sent back. You don't want the tool accidentally returning sensitive data it shouldn't, or worse, returning malicious code or unexpected formatting that could cause injection vulnerabilities in the agent or downstream systems that consume the agent's output.
Sanitize everything, in and out. And we come back to sandboxing one last time here, specifically for tools that might be external plugins or run untrusted code themselves.
Yes. If the MCP server itself involves running code from less trusted sources, like a third-party plugin, then sandboxing at the server's execution level is non-negotiable. Again, using lightweight virtualization or container security profiles like gvisor or strict SACOMP policies to enforce least privilege access for the tool's own code. It ensures the tool itself can only access the specific network, file system, or system resources it absolutely needs to function. It's that layered defense again. Gateway policy controls access to the tool, and server-side sandboxing controls what the tool itself can do.
Got it. Layers are essential. To make this whole ecosystem reliable, the guide stresses the need for strict tooling discipline when people are building these MCP-enabled tools or servers.
Yeah, you can't just wrap any old script with MCP and call it a day. Tools need to be designed for this agentic world. They should be narrowly stoked, do one thing well. They need crystal clear descriptions, especially documenting any potential side effects or constraints accurately so the agent and the governance tools understand the implications of calling it.
Stable interfaces too, I assume.
Absolutely. Stable, versioned APIs are critical. For scalability and resilience, tools should be stateless whenever possible. Externalize any state they need into a proper database or state store. For actions that have side effects, like writing data, they should ideally use asynchronous patterns to avoid blocking the agent, and they must be designed for idempotency.
Right, idempotency, meaning
Good.
safe to retry.
Exactly. The agent or the gateway might need to retry a tool call due to a network blip. The tool needs to handle that gracefully, often using unique request IDs or client keys, so that retrying the action doesn't accidentally result in performing the action twice, like charging a credit card twice.
That production readiness checklist at the end of this section really seems to pull it all together for someone building an MCP server.
It does, it's the synthesis. Ensure robust identity and authorization with least privilege. Implement strict input validation and output sanitization. Wire up comprehensive audit logging and alerts. Configure appropriate rate limits and back pressure mechanisms. Manage any secrets securely, probably via a central vault. Use versioned APIs and have clear deprecation paths. Basically, treat your MCP servers like robust, secure, auditable products, not just internal scripts.
Okay, Section 8 takes everything we've discussed, the ADLC, MCP, security, governance, and synthesizes it into the requirements for a complete agentic AI platform. Looking at the non-functional requirements first, it really feels like the platform is defined by its control points and safety nets.
That's a great way to put it. The non-functional requirements, or NFRs, really emphasize those unified gateways you need, both the MCP gateway for tool access and probably a model gateway for managing access to the LLMs themselves, providing centralized policy enforcement. Security needs to be baked in everywhere. Prompt protection mechanisms, digital signing of all artifacts, code, prompts, models, hardened deployment environments.
And observability, compliance, resilience.
Full telemetry coverage is table stakes for observability. Compliance needs to be built in and continuously monitored against relevant standards like GDPR, APA, whatever applies. And the platform has to be inherently resilient self-healing components, robust failover, plus features for monitoring and controlling the potentially high costs of running these models and tools.
And then the functional requirements, the FRs, define the sophisticated capabilities the agents themselves need to actually perform complex work on this platform.
Right. These are the agent's core competencies. Things like advanced memory management, including how to handle PII safely within memory stores, and integrating effectively with vector databases for RAG or graph databases for relationship tracking. They need sophisticated planning and execution capabilities, reliably decomposing tasks, safely orchestrating sequences of tool calls, knowing when and how to invoke those human-in-the-loop approval workflows.
Interoperability seems key too.
Absolutely. The platform needs to support interoperability standards like MCP, but also probably common formats like OpenAI-compatible APIs or standard OpenAPI specs for tool integration. Robust knowledge management is essential, usually through sophisticated RAG pipelines. Human-agent collaboration features are critical, providing explainability, offering debug modes, allowing humans to easily supervise or correct agents. And finally, performance optimization, maybe using techniques like champion-challenger testing to continuously compare different agent versions or models in production.
It's a massive list of requirements for a platform. To really drive home why all this structure is necessary, the guide concludes with 3 real-world client examples, case studies from highly regulated industries. These aren't theoretical problems. These are about overcoming major operational and compliance roadblocks.
Exactly. These case studies show the pain points that force companies towards this level of rigor.
Let's start with the healthcare payer example, focused on HIPAA compliance. What was their core struggle?
Their big pain point was twofold. First, they had limited historical data they could actually use for training and testing because of strict HIPAA rules around patient PII. Second, their existing chatbot logic was like a black box, opaque, hard to update, and impossible to reliably audit for compliance.
So how did the ADLC approach help?
It directly addressed those issues. To solve the data problem, they implemented the planning phase requirement of generating high-quality synthetic ground truth data, mimicking real patient interactions without using actual PII. This gave them a safe, reliable way to evaluate agent performance. Then, they deployed their agent on a managed, APA-compliant cloud stack, implementing the full ADLC with continuous compliance reviews, full version history tracking for prompts and models, and detailed audit trails for every interaction. This allowed them to demonstrate to regulators that even though the agent had autonomy, its entire life cycle was transparent and auditable, mitigating the compliance risk.
Okay, that makes sense. Next up, the large telecommunication company. Their problem sounds like pure operational chaos related to scale and accuracy.
It was. They were facing a painful 9 to 12-month cycle just to get a new customer service agent variant accurate enough for production. They were drowning trying to track and evaluate tens, maybe hundreds of different agent experiments simultaneously, and they had no integrated framework for evaluation or governance.
Just pure complexity paralysis.
Pretty much. The solution demanded integrated agent ops, tooling a platform that could manage the entire ADLC lifecycle. It required enterprise-grade RBAC that consistently tracked agent identities and permissions from development all the way through to production, ensuring traceability. And critically, they had to establish those centralized governance registries and catalogs we talked about, specifically to prevent agent sprawl, to stop teams from deploying unauthorized shadow AI agents outside the governed process, which was creating huge risks.
Controlling the chaos. And finally, the large financial company, operating under extreme regulations like Sarbanes-Oxley, SOX, and PCI DSS.
Their core challenge was grappling with the implications of non-determinism in a highly regulated space. They recognized that security couldn't just be about scanning source code anymore. It had to cover the entire agentic system, data access controls, the security of embedding models, the integrity of prompts, the array pipelines feeding context to the agent. Every step was a potential compliance risk.
So what did their solution look like?
It required implementing specialized vulnerability scanning, specifically looking for prompt ingestion, model poisoning attempts, and data leakage risks within the AI components. They mandated continuous behavioral evaluation within their CI/CD pipelines, constantly monitoring not just accuracy, but also behavioral drift against approved norms. And most critically, they built sophisticated observability systems designed to capture those highly granular reasoning traces and decision logs, the stuff needed for the reproducible manifests.
So they could prove why a decision was made.
Exactly. When a regulator asks for evidence backing up a specific automated credit decision or transaction approval made 6 months ago, their platform can link that event back to the precise agent version, the exact prompt hash used, the specific model ID, and the logs from every tool invocation involved in that decision. That level of forensic auditability was non-negotiable for them.
Wow. Those examples really hammer home that the ADLC, MCP, and all this governance, it's not just academic theory. It's a direct, heavily engineered response to the massive operational and regulatory hurdles that determine whether a huge, regulated company can even consider deploying autonomous AI safely. #outro. What a deep dive that was. We've really established that making the leap from the predictable, deterministic world of the SDLC to this probabilistic, adaptive ADLC requires a complete shift in operational discipline. It's a full-stack commitment. And things like the Model Context Protocol, MCP, and especially that MCP Gateway Pattern Enforcing Policy seem absolutely essential as the architectural foundation for bringing these powerful AI agents safely into core enterprise functions.
Absolutely. We've seen how this goes way beyond just tweaking standard DevSecOps. It demands fundamentally new focus areas. Things like mandatory layered sandboxing for containment, unique agent identities for true accountability, continuous behavioral evaluation through those experimentation and runtime optimization loops.
And that bedrock of governance.
And the absolute necessity of centralized auditable governance made real through things like comprehensive catalogs and those immutable reproducible manifests. The core tension, the whole challenge really, is managing this newfound autonomy while maintaining rigorous demonstrable control and auditability.
Which leads us perfectly into a final provocative thought for you, our listener, as you think about how this might apply in your own organization. We've established that enterprise agents must be auditable, governable, traceable across their entire lifecycle, from the hash of the prompt that started it all, right through to the logs of the final tool execution.
Right.
So if the primary measure of success for these systems truly shifts away from just raw technical performance and towards continuous compliance, measurable business outcomes, and provable safety, how fundamentally does the role and maybe the power of the centralized governance team, or perhaps the CISO's office, have to change in this emerging agentic enterprise?
Yeah, that's a big question. It feels like they might need to move from being primarily gatekeepers of code deployments to becoming auditors of dynamic behavior and outcomes. Less about checking the source, more about validating the results in the process.
From gatekeepers of code to auditors of behavior, something profound to mull over as you navigate your own path into the agentic enterprise. Thank you so much for joining us for this deep dive.